Okay, here it is. Was out of 30. And so maximum number of x-intercepts, there'll be 1. There's no 0, right? It does cross it no matter what. And the degree is 1, so that's what some of you missed that part, right? And why is it 1? Because technically x has an exponent of 1 on top of it, right? So the degree is 1. That's where I got it from. Okay. Y-intercept is right there. Some of you use the calculator, not a big deal. How many bends will it have? A linear function will, none, right? A linear function will be represented by a straight line. Some of you forgot the end behavior. And so if the leading coefficient is positive, then we're going up like this. So if you said Q3 to Q1 or Q1 to Q3, it doesn't really matter. But that's what I was looking for. The degree of this graph is 2. Some of you just said the degree is quadratic. You have to tell me the degree is 2 because there's an x squared there. Okay. Leading coefficient is positive. I had a lot of negatives there, so I'm a little curious what happened there. But if the leading coefficient is positive, it's going to be opening up. If it's negative, it opens down. The domain and range. So for the domain, it's all real numbers, or you could go negative infinity to positive infinity. There was a bit of a I accepted essentially anything that was. Some of you said this is 3. Like you identified that because we're going up by 2 here. This is 3, so I accepted everything in there. But y is greater than or equal to 2.2. Maybe write that down. Or you go 2.2 to infinity. If there's a number, there's a big chance that that's a square bracket. It's included, but not infinity. Infinity should never have a square bracket around it. Okay, there we go. You can't contain it. Some of you, scatter plots. Some of you said this is cubic or quadratic, but the fact is that it never really says there's a constant increase. So a linear is the best. Okay, it keeps on, like if you look at the scatter plot, yes, they're not all perfectly lined up, but there's no indication that it does this. There's no indication that it does down and then back up. Like it doesn't have like a very, sharp turn or anything like that. So this is linear. Okay, so StatCalc LinReg, this is the equation that I was expecting. Some of you had squared. See, if you said squared quadratic, I would have taken off a mark and given it to you here, but a lot of you missed the fact that there was an e to the -4, I believe, or e to the -5. So this shouldn't be, some of you wrote down 1 point something. It's actually 0.0001 x squared. Yeah. Because like if you do a cubic regression, it will, even a quadratic, it will at some point curve because it's how it behaves, right? But it will try to, like if you have a straight line and you go quadratic, it's going to make a parabola that has a very slight bend among these points. But then eventually it will do this, right? So that's not what the data indicates. And then this one, some of you missed this. Make sure you write it down if it's 10 days, but here it's time and hours. So if you just plugged in 10, it's as if you're saying 10 hours. So it's 240 hours. That's what was supposed to go into the second trace 1x is 240. Okay. Next. For the most part, this was done very well. Some rounding issues. Sometimes I believe you entered the wrong equation or you entered one number slightly differently. So I would just take off half here and there, but that's it. Max height is 1340 based on the vertex. The graph was done very well for the most part. You included all the important components. It does hit the ground, right? At least, right? We're told like how long will the plane travel before it hits the ground, so we're assuming it hits the ground. And so for your domain and range, in this case, right, domain is from 0 till it hits the ground, like that's my time. And the range, some of you went with your y-intercept, but if you think about it, you go as low as 0, right? So you want to travel along the y-axis and see where does the graph exist, right? It goes from 0 all the way to the highest point. Okay, so don't let this throw you off. And then I was impressed how many did know how to do this one. I didn't warn you, and it was only worth a mark. But if you build your study sheet, you know what to do here. This is grouping within an arrangement. So you're displaying all 7 like this, but you're keeping 3 of them together. So this isn't combinations. Okay, this combinations is when you're making groups, right? Where you're not displaying order doesn't matter. Here, order does matter. So we use factorial. I'm gonna show you a funny. Speaking of factorials, right? If you say 0 very loudly, it eventually turns into 1. That's the joke, right? 0 factorial is 1. Anyways, you can use that in English, maybe. So here, you're supposed to just fill in the table, done very well. No, like very few issues. Maybe some of you made a little calculation error. And then this is definitely a quadratic because I tell you, and also because this type does behave like a quadratic if you plot. I mean, if you plot, you would probably not, like, I think the plot is like, it looks very linear almost, but that's why I did tell you, right? I use quadratic in this case. The maximum possible revenue, you need to use the price of this. So some of you failed to say that it's the 354 that we're after. The lowest price to get 1500, you let y2 equals 1500. The lowest is 220. There was another one. What was the other one? Anybody? 380? I'm not sure, but this is the lowest price, so we got to go with a 220. A lot of you got this one right. I'm not worried about the last one here. Yeah, it has 2 bends and it needs to have 3 x-intercepts. So simple as that. Backside, I did say cubic regression, so don't argue with it, right? Don't be like, I think this should be a linear. Like, don't do that, right? If the question just says find the cubic, it is a cubic. And make sure you have x squared, x cubed, x, right? Just follow the format you have on your calculator. Here it says that the stretch where the height is above 15 needs railing. So there are 2 horizontal distances. So from here to here, horizontally, it's above 15. So we subtract those 2 to get 13.33 meters. Okay. The greatest height, you just go second trace max. And so the greatest height is 18.25 of this track. Then graph it. So when you're graphing it, you want to use a combination. Like you kind of want to look at what's on your calculator. And if this point isn't given, you want to find it, right? So I did find my min, my y-intercept, my x-intercept, and the max is already over here, right? So I'm making sure all those important points show up, okay? So you have height, you have distance, equation, perfect shape, and there you go. 3 marks for that. And your domain and range, you go from domain of 0 horizontally till the track stops, because you can't, like if you kept going, this graph would go below the x-axis, right? Or if you went to negative distance, this would go outside here, but we want to contain it, okay? My range goes from 0, right, all the way to the highest point, which is 18.25. There is your quest. Hopefully you learned something. You always want to